Assalamualaikum, a very good evening. Today we would like to discuss our project. The title of our project is Injection Duration at Crankshaft and Camshaft Signel. There is 6 members of our group. First we have Afshin anak laki Sawara Pandi. Second we have Komal and Ravi. Third we have me, Muhammad Asif bin Abdul Rahim. Next we have Muhammad Isham bin Muhammad Azharan. Next we have Muhammad Hafsuddin bin Muhammad Anizam. And then last but not least, Nur Anis binti Safi. I would like to talk about introduction. The fuel injection time and RPM are essential parameters in an internal combustion engine, influencing efficiency, performance, and environmental effect. The calculated load value and injection time have an influence on the air-fuel mixture composition. The common rail direct injection (CRDI) system is a new fuel injection technology for diesel engine that introduce high pressure fuel into the combustion chamber at the appropriate time and volume to increase performance, fuel efficiency, and emission. This practical experience aims to close the gap between theoretical knowledge and the real-world application, therefore improving student comprehension of engine change.
So, moving on to the objectives, we or students should be able to diagnose and troubleshoot problems with a vehicle using an onboard diagnostic scanner. And secondly, we must be able to use the oscilloscope to analyze the waveform of electronic signals. Thirdly, we must be able to measure multiple electrical properties by using a multimeter. Finally, we were able to identify the input, output, and correction factors of the engine map.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Anis binti Safi, matric number AN210061, and I will explain the procedure for our project. So first of all, we turn on the CRDI trainer, then we connect the OBD scanner to trainer. Also, we connect the oscilloscope to injector and cam position sensor at the trainer. Then at the OBD, we select vehicle type Hyundai Santa Fe year 2030, and the initial conditions of the trainer are also set, and these initial conditions can be referred to table 1. After that, in the OBD, we select several parameters to be displayed in OBD, and these parameters include engine speed, accelerator position sensor, and calculated load value. Then we set engine speed and throttle position at the trainer according to table 3. Next, to start, we turn on the ignition key and set minimum engine speed at 600 rpm. So in this project, we use minimum and maximum engine speed. So for the minimum is at 600 rpm, maximum at 2000 rpm. Then we record the calculated load value in the OBD and injection duration from oscilloscope. Then we repeat the experiment with maximum engine speed of 2000 rpm. After record all data and turn off the ignition key, we illustrate the results into 2D graph. So this is the initial conditions that we set at the trainer. Table 2 is the selected readings in the OBD, and table 3 is the experiment matrix.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Isham Muhammad Azharan. My matric number is CN210113. Okay. Today I would like to talk about the observation for our group project. If you can see, we have two data. The first one is at 600 rpm and the second one is at 2000 rpm. Okay. The calculated load value remain constant at 100% from 0 to 100 of the total position after the machine hit 600 rpm. Next, the injection duration was decreased from 102.2 millisecond to 101.7 millisecond at 0 to 30% of the total position. After that, The injection duration was maintained at 101.6 milliseconds at 40 to 50% of the total position. At 50% and 70% of the total position, the injection duration was increased zero, from 101.5 milliseconds to 101.6 milliseconds. Next, the injection duration was maintained at 101.5 milliseconds with the total position 80% to 90%. After that, the injection duration was decreased to 101.3 milliseconds at the total position 100. Okay, next we're going to the 2000 RPM. The calculate load value was increased from 0% to 100%, while the total position is 0 to 100%. Next, when the total position was at 0% and 0% to 10%, the injection duration was increased from 0.3452 millisecond to 30.05 millisecond. After that, the injection duration was decreased to 29.8 millisecond at the total position 20%. At 30% and 40% of total position, the value of injection duration was maintained at 29.78 millisecond and dropped back from 29.67 to 29.53 millisecond at 50% to 70% of total position. Next, at 80% of the total position, the injection duration was raised to 29.55 milliseconds. Lastly, the injection duration was decreased from 29.39 milliseconds at the 90% and 100% total position. Okay, that's all for me. Thank you. And I will pass to next person. Thank you.
Assalamualaikum. My name is Muhammad Fizuddin bin Muhammad Nizam, AN 210053. And I will present about the result from the graph. At engine speed of 600 RPM, the calculated load value are constant. And at the throttle position from 0% to 100%, the injection duration is slowly decreasing. Next is the result of engine speed at 2000 RPM. At the throttle position from 30% to 100%, the calculated load value are constant. And at throttle position from 10% to 100%, the injection duration is slowly decreasing.
Good day. I'll be explaining about the discussion for our project. So the above diagram shows the comparison for higher RPM and lower RPM for the injection duration versus the throttle position. The injection duration is an internal combustion engine which is crucial for fuel delivery, influenced by factors like RPM and throttle position sensor readings. Now I'll be explaining about the RPM influence. Lower RPM requires longer injection durations. It is because it ensures sufficient fuel during the longer intake stroke. Whereas at higher RPM, shorter injection times is needed. It is because less time for fuel to burn between the cycles and to maintain proper air-fuel ratios and engine efficiency. Now, I'll be explaining about the throttle position impact. Longer injection times occurs at higher throttle position because it handles increased air intake for higher power production. Whereas at lower throttle settings, shorter injection times occurs because to prevent overfueling and preserve efficiency. To support my discussion here, from the graph obtained for the result, at 2000 RPM, the injection duration recorded is 29.32 at throttle position 100, whereas at 600 RPM for the injection duration recorded is 101.3 at throttle position 100.
Throughout this project, we can conclude that at low engine speed, the injection duration tends to be shorter, while at higher engine speed, there is a longer injection duration to deliver the required fuel for efficient combustion. The injection duration is a crucial parameter affecting the combustion process, fuel efficiency and emissions in a diesel engine. And the injection duration is calculated to achieve efficient combustion and power generation while minimizing emissions. The significance of common rail direct injection CRDI in this project is that it has precise control over fuel injection, allowing for flexibility and optimization of combustion. I think that's all from our group. Thank you.